Hello everyone, welcome to the memory allocation in C presentation video. In this video we are going to see what is the memory layout of C and then the types of memory allocation. This is what we are going to see in this video. So first of all, what is the memory layout of a C program? So this is the structure of memory layout. There are different segments we are having. Actually we are having totally 5 segments. So here bottom, that is started with lower address. At the top is ended with higher address. So lowest part segment is text or code segment. So what is the use of this text or code segment? That is used for storing program instruction. So here I have given what is the code text segment usage. This is used to store the compiled program instructions. The instructions are like main, printf. And next second segment is data segment. So what is the use of data segment is, this is used for storing initialized global or static variables. So data segment, that is used for storing global and static variables that is initialized data, initialized global and static variables. The third segment is BSS. So BSS stands for block started by symbol. What is the use of this is, this is used to store uninitialized static or global variables. So BSS, that is used for storing uninitialized global and static variables. Next fourth segment, that is heap. This is used for dynamic memory allocation. So here the dynamic memory allocation functions like malloc, calloc, realloc, free, all these functions are stored in this fourth segment called heap segment. Next stack, last one, stack segment. So what is the use of this stack segment is, this is used for storing local variables and function parameters and return as addresses. So all these are going to be stored in the last higher segment called stack segment. And once memory is allocated in C, this will be deallocated automatically when functions are called and written here. So this is what about the layout of memory layout of C programming. Next, memory allocation. How there will be a memory allocation is happening. So actually there are two different types of memory allocation. One is static memory allocation, dynamic memory allocation. So memory allocation means what? This is nothing but it is the process of reserving memory for different variables, arrays and other data structures in the program, in the C program. This is what is a memory allocation. So first, so there are two types. One is static memory allocation, other one is dynamic memory allocation. So now we are going to see what is a static memory allocation. So what is static, what is dynamic? In the name itself we can say static means some fixed, there is no change, fixed value, that is what static. So static memory allocation, it is nothing but memory is allocated at here. Memory allocation is happening during compile time. When your program is started to compile, when your program is compiling, at the time the memory is allocated for your C program, and the size of memory is fixed here before the program starts executing and cannot be changed during runtime. Once the memory is fixed, we cannot change the memory size, we cannot increase the memory size or we cannot decrease the memory size. That is what in static memory allocation. Here everything is managed by compiler and memory is automatically deallocated when the program ends or function returns. And next, this is faster than dynamic memory allocation. So static means that is a fixed memory size. We cannot change that memory once it is fixed. and this is happening during compile time. Memory allocation is happening during compile time. Next one example, here I have created one array variable. So first of all we are starting with library files stdio.h, and inside main function I have created an array function that is an integer type, and here I have created for 5 elements. So array of 5, arr 5. Inside that I am storing 5 values, integer value 10, 20, 30, 40, 50. So in my first array location, that is array of 0, 10 value is stored, array of 1, 20, excuse me, array of 2, I am storing 30 as the value, array of 4, I am storing 40 as the value, in fifth last location I am storing 50 as the value. Now we are going to print all the values. So for this I am using one for loop, for int I equal to 0, I less than 5, I plus plus condition. This condition, this loop is for 5 variables, and inside that loop I am printing all my values. So printf %d, this is integer data type, so we have to use the format specified %d, comma array of I. So if my I equal to 0, array of 0 will be printed. So what is my array of 0 value? That is 10. And next I equal to 1 means array of 1 will be printed. Next array of 2, array of 3 and array of 4. So all the 5 elements will be displayed here. After displaying everything, I am closing my program with return 0. So this won't return any value. So my output will be like 10, 20, 30, 40, 50. If I want to print all these value one by one, means how to give printf %d \n. If I am giving \n, if I am adding that in my printf line, so I will get the output like 10. In the first line I will get 10, in the second line I will get 20, after that 30 in third line, fourth line 50, 40, in fifth line 50. So like that I can get my output. Here I have not used that \n, so all the output will be displayed in the same line. So this is what the example for static memory allocation. Here I have allocated memory for one array variable, that is for 5 elements. Once it is fixed, I cannot increase that for more number of variables, or I cannot reduce 5 into some other value. So once it is fixed for 5 variable, it won't be changed. This is what about static memory allocation. Next, dynamic memory allocation. So dynamic in the sense what? There won't be any fixed value. So it is we can change the memory size. We can increase the memory size as per our requirement, and or we can reduce our memory size. This is what about dynamic memory allocation. So when this is happening? During runtime or during program execution time, the dynamic memory allocation is happening. So static memory allocation, that is happening during compile time. Dynamic memory allocation, that is happening during runtime. And in static, once the memory size is fixed, we cannot change the size of memory, but in dynamic we can change the size of memory. We can increase or we can decrease. So this is more flexible and efficient. And where the memory is allocated for dynamic memory? So in the heap, from the heap, dynamic memory is allocated from the heap using functions provided in the stdlib.h header file. So if I want to use dynamic memory allocation, I have to include one more header file along with stdlib.h. So what is the header file? stdlib.h, standard library file.h. So what are the functions we are having in this dynamic memory allocation? There are four functions. One is malloc, otherwise we can call it as malloc, and second one calloc or scalloc, and realloc free. So what is malloc means? Malloc that is used for allocating some block of memory. Here memory is not initialized. that is uninitialized. So here some block of memory will be allocated when you are using malloc function. The memory is not initialized here. Next, second function calloc. So here also some block of memory will be allocated, but the memory will be initialized with 0 value. That is what in calloc function. Next, realloc. So using malloc or dalloc, I am allocating some memory size. In future, if I want to increase the memory size or if I want to reduce that memory size, means that is possible using realloc. So it is used to changes the size of previously allocated memory. That is the use of realloc function. Next, free. So here after once memory is allocated, we need to deallocate that memory by using free function. So these are all the different functions used in dynamic memory allocation. I hope you understood about static memory allocation and dynamic memory allocation. Thank you for watching.